Children, welcome to Evolve Science classes. Today quickly we are going to discuss about the graphical representation of motion. Motion of an object can be represented graphically by two types of graphs. One is the distance time graph, another is the speed time graph. This distance time graph can also be written as displacement time graph or ST graph. The speed time graph can also be termed as velocity time graph or VT graph. For distance time graph or ST graph, it is of three types. When the body is at rest, then ST graph is a straight line parallel to the time axis. We are talking of this line. This is parallel to the time axis. Here what we see, time is 0, S is also 0. So the body is at rest at no movement, with no movement. Then in this graph, the second graph, where time is 0 and the distance is not equal to 0, that means the distance is moved but the time is not equal to 0. Time is also moved. So body is at rest at the same distance. Suppose an object is kept at this is an object kept at 9 a.m. The object is kept here, for example. At 9:20 also you find the object is kept here only. So there is no change of the object's position, but the time is changing. So body is still at rest. Okay. For uniform motion or uniform speed or uniform velocity of a body, what could be the graph here? Let us find out. ST graph is a straight line inclined at some angle with the x-axis. X-axis is this. It is always taken as the time. So uniform motion will be just like an inclined plane. Okay. When this happens, when the time is 0 and S, that is the distance, is also 0. The ST graph is a straight line starting from the origin. Now when T is 0, time is 0, but S is that the distance is not equal to 0. Time is 0, but the distance is not equal to 0. Here the ST graph is a straight line but not starting from the origin. Origin is this. We say distance is not 0, that means the already travelled the distance. Some velocity has already been attained and then it is increasing, uniformly moving ahead. The graph remains like this. Another. For non-uniform motion. For non-uniform motion. For uniform motion you will always get a slope as you just now saw. For non-uniform motion or non-uniform speed or non-uniform velocity, it will always be a curve like this. Whether small distance is travelled or not, it will be a small curve like this. This curve in this is t equal to 0, time is 0 and distance is also 0. Here time is 0 but distance is not equal to 0. Here ST graph is a curve starting from the origin and the speed is increasing. When the speed increases, it is moving up. Here when the speed is increasing, it is moving up. Can you see this is moving up? Here this is moving up. But in the other case, you will find that the speed is also decreasing. In this picture you find the speed is coming down. This picture also you find the speed is coming down. Here the passage of time, the speed is decreasing, means it may be getting slower. Then for the speed time graph, that is the VT graph, it can be of three types again. When the speed of the body is constant, that is u is equal to v and acceleration is equal to 0. For this, it will be a straight line. Can you see the straight line here? It will be a straight line like this and parallel to the time axis. When the speed changes at uniform rate, that means it is increasing but uniformly, then it will become a slope, just like this, which we saw in the speed time graph. Here it's a uniform acceleration. We term it as uniform acceleration. But acceleration is never equal to 0. Here time is equal to 0. Initial velocity is not equal to 0. It has already moved certain distance. Then it has taken acceleration. So the movement is shown here. It's not from the starting point, but it has already moved a certain point and then accelerated. If the slope is moving upwards, we call it as acceleration, positive A. There will be some graph where you will find there is retardation or negative A. Here we find acceleration is going down. So here it is negative A or deceleration. When the speed changes at an uniform rate, non-uniform rate, when the speed increases at a non-uniform rate, that is non-uniform acceleration. Same way we will get a curve. We will get a curve here like this. As you find here, the acceleration also, it is moving with a curve. And it also can move down in case of deceleration or get down like this, moving down like this. This is called as retardation. For acceleration, things will move like this or straight like this. This is for uniform acceleration. This is for non-uniform acceleration. But this is retardation or non-uniform retardation. Now, how can we calculate the graph? This I have already discussed in my previous video. So, for that you should see to the video and do accordingly. Thank you.